walked into the office this morning. I'm like, who's covering me on Friday? And they were like, well, they have it written down my name, and then there's no one to fill in my sub slots. And I'm like, okay. So I honestly don't know if you're gonna have extra time. It's a little bit rough. But listen, we actually shortcutted a section. We did not do section 3.5 for this test so that you guys could get it out of your life before Thanksgiving break. Which means there's a whole huge long answer that you're not doing on the test. Which means theoretically we could fit it in a class period. Does that make sense?
Yeah.
So I'm gonna try to have as much information for you guys as possible by tomorrow. They're working on it today, I think. It was one of those, like, they thought it was taken care of and it wasn't, so they're checking it out. So I don't know who your sub's gonna be necessarily, but the test is like a whole long answer and a big long answer, shorter than it was going to be, so that's good.
How many multiple choice?
14? No, sorry. I think the total test number is 14. I think 3 of those are long answers, so then that would make about 11 multiple choice. 10 or 11 multiple choice, 3-ish long answer, but like the normal long answer, not like a whole page of long answer, which is what it would have been. So. Well, and good thing I gave partial credit. If I can see your work defending a proper approach, even if it wasn't a perfect solution. Oh, I like that. A proper approach. Anyway, coming back. A reason, a justification for partial credit on multiple choice at this point. Although I totally support Mrs. Leon's like hard stance.
Ooh, yeah.
You guys are writing down the very final forever card of this chapter if you did not write it down yet. But there's one extra little baby clue I think would be very, 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 very helpful that comes from that page over there. This is the card, this is the concept, that's the process. So what do you see over there? Same as the sign chart for F prime. What? Sign chart? But this doesn't, okay. How does a sign chart for F prime start? I'm going to get my green pen out because technically it's review. How does a sign chart, or how does an analysis of increasing and decreasing, let's call it what it is, how does an increasing, decreasing analysis work? First, so we're not doing a sign chart, but we are using the first derivative, but how? For forever card number 27, we are using the first derivative to find us these. We're using the first derivative to find us these. Because look at the card. Isn't that where the card starts? No, it says second. But these guys are the only possible candidates for these, right? Okay. So I need to start, even though it's awkward, even though we're in section 3.4, we are so past the first derivative. No, we're not, because for relative extremement, that's how or where we have to look. We have to get these guys of that guy. And yes, I'm being very general just to let them focus. So we do this. True? However, coming back, don't worry, none of them are state the cards. Not for you either. You're welcome. But it is like fill-in. Here's what else you need to see from over here. So we go back to the first derivative, even though we're in section 3.4. Even though it says maybe to use this guy. We go back to the first derivative and we say, hey, who are your critical numbers? Or I should say, who are F's critical numbers, but find the critical numbers. Thinking about the domain. But then what changes? Why did I cross out sign chart? What is it saying I do to these? Oh, that's weird. Usually we make a number line and we put the critical numbers and we test points on either side of them, right? This one says, no. Take them and plug into, if I plug into him, it'll be 0 or DNE. That doesn't help. I'm not plugging it into the first, I'm plugging it into the second. Oh, wait a minute. What does the second derivative tell me? If I plug something in, an x value into the second derivative, it's the sign chart of the second derivative, it's the section title of 3.4. If I plug into the second derivative and I get a positive or a negative, oh, what am I doing? I'm concaving, I'm curvaturing, I'm showing curve, right? Because what does the second derivative tell me about? Curvature, curved up or curved down. The whole curved up? Maybe not. Maybe it's like an E sort of thing. Maybe it's an E sort of thing. Curved down all the way down? Maybe it's an LN sort of thing. But either way, curved up-ish and curved down-ish has that type of curve. So if I'm plugging one of these guys into the second derivative and there is curvature, does that mean that this guy would have been a 0 or a DNE? If there's curvature at that point, would it be a 0 first derivative or a DNE first derivative?
0.
Because it had to have been a smooth turn to have a curve.
Can you talk?
Think of a basic graph that does not have a smooth turn but still has a turn. What's a basic graph with a sharp point?
Absolute value.
Absolute value. Okay. So if I was to test the concavity at the absolute value critical number, boop, is it going to have concavity? There's no curve. So if there's no curve and I try to plug in, well, does this make a little more sense then? If I try to plug into the second derivative and I have no concavity, I have no curvature, well, forget it. I don't know. I have to go back to the first derivative and I have to look on one side and I have to look on the other of the first derivative and figure out what it's doing. But if I have the second derivative anyway, or if I can find the second derivative fairly quickly anyway, I can take this guy, and the key that I need you to write down that you need to remember is what do we do to the critical numbers? We plug them in, right?
Plug it in.
We plug them in. So we're going to find the critical numbers, and then we're going to plug into, there you go. We're going to take F, I know it's weird, you're going from one derivative to the other derivative. It's kind of like they're coming together in a weird way. Critical numbers are the only possible candidates for relative extrema. They're the only ones. If they say anything about a relative min or a relative max, we got to look here, and we got to look at his zeros and DNEs. But once we have them, if we have a second derivative, we could plug it in, and say, hey, is there curvature? Sweet. If there's curvature, does it make sense if the curvature is somehow up and there's a horizontal tangent, it has to be a min? My visual people, this will help if you figure out how to visualize what's going on. Does it make sense if the curvature is down, as indicated by the second derivative being negative? That you will have. Right? And if there's no curvature, well, I don't know, I have to go to the first derivative section. It is what it is. So, let's go forward just a little bit. What if I was to, now, I have a graph up there just so we can peek at it. If I was to give you guys this example problem right now, which, why are you going to start to freak out just a little bit?
Quotient rule with a chain rule.
We're trying to be efficient with our class time, and if we're trying to be efficient with our class time, what are we going to waste half of class doing this morning?
Right.
Taking the first and second derivative, which is why on Monday night, how did I tell you to start homework number 20 even before you have all the concepts? Take the first and second derivatives, and why did I put an answer key for first and second derivatives in your whole classroom homework assignment? So you know if you did it right or wrong, and to some extent, if you got stuck, couldn't you just kind of like use the derivative and be like, oh, I'll figure it out later and ask her, right? Okay, because for this test on Friday, do you have to be a total derivative champion of the craziest, nastiest, or most horrible derivatives or functions? No, I want you to know the concepts. Now, is it good to know your product rule?
Yes.
Quotient rule, LNB,
Yeah.
trig, just in case they show up once. Square roots, what to do with them? Good thing you asked about 2 yesterday, right? Like, right? Because they were the nasty ones. Like she totally looked ahead for you. But anyway, could we do this guy? Yeah. Would it take a lot of time? Yeah. So, why did I have you basically fully attempting homework number 20 for this morning? So that you've already tried, you've already derived, and we can just go talk about your questions and do a full problem if we need to from beginning to end, but of one that you're invested in, that you're like, yeah, help please. Instead of like some other random problem that quite realistically is harder than anything you're going to see on test on Friday. So is it okay if I just come back here and I just say, you know, if we had all the time in the world, it'd be great, but let's go ahead and just get rid of him. How about this guy? Why am I not as afraid of him?
Just do LN.
Not all that. Don't do that. Let's tackle this guy. He's shorter, he's easier, he's nicer, no quotient rule, no chain rule. But how would I derive him? Why do I have him up on the screen? It's an E. Were there any E's in homework number 20?
Yes.
Okay. E's can be a little. Some of you still don't have the derivative rule perfect. So, derivative of e to the u is? E to the u. He's the nicest one, like a phoenix rising from its own ashes. Come on, the derivative of e to the u is e to the u times u prime. Can I not give you guys that coefficient? Francois Libanais once said, commenting about the beauty of the exponential function, who has not been, it was on a calculus lecture a few years ago, someone that came to a phoenix, it was actually pretty cool. Who has not been amazed to see that the derivative of e to the x, like a phoenix, no. That the function e to x, like a phoenix rising again from its own ashes, is its own derivative, something like that. Anyway, that was close. It was in like the midst of this book, and he decides to go all poetic. It's pretty cool. And then there's Harry Potter that's like Phoenix, and you just don't even think about anything else. But that's okay. E to the u. E to the u. If I'm trying to find y prime, I know dy dx. E to the u times. How many of you guys might have had some issues deriving this? Kyle this morning was asking me about it. Deriving that. How do we derive negative 3 over x? Can we do the basics, which can get tricky? And would we put a parenthesis around it? How many of you guys just vote, and we'll just do the majority wins as far as what direction to take? Who would do the quotient rule? It's legal? Quotient rule. Really? No, I do not believe no one would do the quotient rule.
I'm kind of blanking on what it is.
You could do bottom d top minus top d bottom. It's not a memorized thing. Bottom d top minus top d bottom all over bottom squared. You could do the quotient rule. What's the other way? Okay, so raise your hand. Who would do the quotient rule because it's a quotient? Okay, so we're going to do the quotient rule. The rest of you guys, rewrite it, derive it. All done? Yeah. Formally submit it, put it on my desk, and then just turn off the screen. Okay.
Do I need to like pull the thing up?
Oh yeah, you pull the thing up. It's all twisted weirdly.
It's
Yeah. The rest of you guys, you would rewrite it. So we have bottom d top. Wait, what's the derivative of 3? Negative 3. Oh. Minus top d bottom all over bottom squared. True?
Yeah.
Which is the same thing as 0 minus negative 3 is plus 3. So e times 3 would be 3e to the negative 3 over x all over. Woo! That was fun. Okay.
Oh wait, there's more.
Wait, I'm not pitchforking right now? Why not?
Because you need 5 seconds.
Why?
Because we're looking for points of inflection.
And even beyond that, points of inflection have to do with concavity, and concavity is always tied to which derivative? The second one. Now, remember the opener from yesterday, the day before? If I give you the second derivative, aren't you like singing praises to Jesus and the light shining down? Because if I give you the second derivative, what are you going to do? Go derive it?
No.
I'm just going to use it. If I give you the first derivative for, wait a minute, what would they be asking? What behavior, what analysis, what keywords would tell you first derivative? If they ask you an increasing or decreasing question on Friday, if the multiple choice question asks you increasing, decreasing, and I give you the derivative, once again, right? Choir, singing, like, angelic voices, because all you have to do is use it, right? But what did they give us in this one? No derivatives. So then if we see concavity, you guys are seeing how I'm trying to train your brains for the test on Friday to see keywords, or the review to see keywords, or the practice test to see keywords, right? Good. So taking a second derivative, and second derivative, I am definitely doing a quotient rule. Sorry, I have a top and I have a bottom. Those of you guys that rewrote, you would have seen this as negative 3, x to the negative 1, bring down the negative 1, positive 3 over x squared. It's the exact same thing. Rewriting's cool. Quotient rule works. Rewriting's cool. Quotient rule works. Y double prime equals bottom d top. Oh, you got to be kidding me. I have to do another e to the u times. Good thing we just figured out what it ends up being. Bottom d top 3 e to the u times u prime minus top. You guys see why I'm doing this as an example? Top d bottom. We're trying to think of analyzing for points of inflection and concavity.
X squared.
Thank you. I got distracted trying to make it. Yeah, X and 4, good. If I'm trying to analyze for concavity, I want to get to a sign chart of the second derivative, and I want to see if the signs change. If the signs don't change, the pip, nope, doesn't pass. possible is not actual, but the sign does change at the second derivative, then it's an actual. Okay, that's a forever card. But, anybody freaking out just a little bit? So why am I first going to do this? Because, oh, that's nice.
Because it's on the same side.
Complex fraction gone. It's on the same same collection of terms, right? On this side of the minus sign. Totally legal.
Can you take that?
But why did I have my green pen? Why did I pick that up?
3 even.
Because there's some stuff shared. Nice. So I can, okay, well the x squared simplifies, so I can't take out any x's. But I can take out a 3 and an e and a negative 3 over x. And I end up with 3 minus 2x. My guys that have been doing homeworks and doing like critical numbers and points, pips, technically, because before the sign chart. Critical numbers and pips, zeros and DNEs. Whenever you see an exponential piece, e to the, or 3 to the, or anything else, does this ever get you a 0? Because they always have horizontal asymptotes, they'll always skim. Should I think about setting him equal to 0 from algebra? We set all the factors equal to 0? Yes, I should think about it. But if I set just a plain old exponential, no plus, no minus, careful, no plus, no minus, so plain old exponential, how would I solve for this guy? Wouldn't I take ln of both sides?
Yes.
And what's ln of 0? Nothing. So there is no way for an exponential piece to be 0 when I'm thinking about my critical numbers. Sorry, my pips. But what do I have? Oh, x equals 0. I have x equals 3/2. Double check my math real fast. Look good?
Yeah.
But why?
Oh.
Am I going to cross it? What? 0.
Because if you plug in.
Did we think about domain?
No.
Which was why at the very beginning of any analysis for increasing, decreasing concavity, relative extrema, it always says in the forever cards, f must exist. F must be continuous. F. Well, for our practical purposes, we must check the domain of f. What could x not be? Because he was an old lady denominator way back here.
Old lady.
Oof. So then could you be, well, wait a minute. Should we still use him in the sign chart for the second derivative?
Yeah.
You guys doing homework number 20, this is review. All we have to do now is throw in our 0, throw in our 3/2, but at my 0, why am I going to like make him dotted? Does he actually exist?
No.
He's a vertical asymptote, probably, number over 0, but anyway, he doesn't actually exist. So can I, well, let's just do our analysis. Our analysis for the second derivative, concavity. Were you guys plugging into f double primes last night?
Yes, ma'am.
I hope so. What were you plugging in? Oh, you plug in that. No. We plug in on either side of a sign chart, right?
So -1.
So -1, sure. So a negative over a negative is a positive. E to the positive is a positive. Okay, that's fun. What's something between 0 and 3/2?
1.
E to the negative 3 over 1. Is a negative?
That's not.
No. What does a negative exponent mean?
Like it's reciprocal. 1 over.
Doesn't it just mean it's 1 over 3 to the x?
Yes. Huh?
So 1 over 3 to the 1, isn't that positive?
Yeah.
And then plugging in 2 or 10 or 100 or a million, isn't that going to be positive?
There is no.
Who is this guy? If we were talking about f prime, we could say things like he's increasing, because f prime is just 1 prime back. But if I'm talking about f, now, in homework, if it talks about concavity, we don't care about f prime, we don't care about f. What kind of curvature does this signify from the concavity test? Concave up. If you're a positive person, maybe you smile. Concave up, concave up, concave up. How is it concave up? I don't know exactly unless I were to do 2 different sign charts and put all the information together about the increasing, decreasing, and concavity. But that's after Thanksgiving. Adam.
For the 3/2, like if you plug in 2, wouldn't it be negative? Because like 3 minus 2 times 4, so -1.
What's Adam looking at? What's he looking at?
The original function.
Where was I plugging in?
The original function.
Where's Adam looking?
F double prime.
Oh, how quickly. You
I
Minds
knew
can
that-
be swayed.
I knew it was a little weird that you were going into the
How did you
original
know
question.
that? You guys are so cute.
I was
So
like,
you let that happen?
I was just like, you're welcome. And I never know if I actually made the mistake or if I'm just covering up for it. Well, or using it as a learning opportunity.
no, Adam.
Can you totally understand sign charts? Can you totally understand sign charts and still mess it up?
Do that.
Where are you supposed to be plugging it in?
Yes, prime.
At the prime time. So I went way back here because we were talking about domain, and my brain just like, oh, you were just there, go back. The problem is, some of your brains are going to go back here because you're so used to the first derivative sign charts, or more used to it, when in reality, where does your brain need to, let's go here. The whole point is we're trying to analyze the sign of the second derivative, right? So hold on, if we were to come back in here, now remember, this guy's not gone, he just didn't have a 0. What did we just talk about with e to the negative 3x, all the things that we plugged in? What is his sign always going to be? He's always going to be positive, but what extra piece do we, oh, he's always positive, but what extra piece do we have? So, is it important for your brain to realize that's always positive? Yeah, that's helpful. And that's always positive, yeah, okay, just look here. So if I plug in a -1, a negative times a negative is a positive, oh, okay, yeah, that was positive. But if I plug in a 1, 3 minus 2, oh, that's a positive. But if I plug in a 2, okay, there was a sign change. And if we were talking about f prime, remember, one derivative away is increasing, decreasing, so we could talk about that. But we're talking about concavity, so we're going back to analyzing f. We have concave up, and concave down. But guys, even if there had been a sign change, right here, I wouldn't have been allowed to call him a point of inflection, very common mistake. AP guys love to put the vertical asymptote here instead of there, so there is a sign change, and you're like, it's a point of inflection, and they're like, no, it's not, it doesn't exist. But the signs didn't change, you shouldn't have made that mistake anyway. But what's going on at 3/2, a point that does exist? At this possible inflection point, what happens to the curvature before and after? It changes, and if the curvature changes, what do we call that possible inflection point?
Relative.
An actual inflection point. Now the AP doesn't call him an actual, just your head is saying, oh, it's actually 1. 1 what? 1 inflection point. So the inflection point is at 3, 2. When you guys are grading your homework, did you notice that some of their relative mins, relative maxes, and inflection points had an x and a y? It wasn't an interval, it was an x and a y. What they're doing is taking it and plugging it in. If we plug in 3/2, the 3 is reduced, the 2 goes up, and I think you end up with 1/e². Anybody plug it in here? And if we're analyzing for concavity, we would say something like this function is concave up and then concave down on, and now it's time for x intervals, not points, but beginnings and endings. Why am I saying concave up on -infinity to 0, and then also 0 to 3/2? Why didn't I just go from -infinity to 3/2? The function doesn't exist at 0. If I include 0 saying that this function is concave up at a point that doesn't exist, the AP guys are like, oh, poor kid, -1. Even if your analysis is perfect. You'll get points for that, but can't make mistakes, so they take points off. Can't say illegal things, or they take points off. Concave down, 3/2 to infinity. I realized from something someone said this morning when they were asking me a question, I haven't actually written out the long form of your answers. I'm just saying, hey, do you see it? Cool, you could write it. Okay, we wrote it. Kiddos, we've rehashed section 3.4 pretty much in its entirety. So I'm going to go ahead and zip on over to 3.4 answers so that we can grade. Now, remember, 3.4 derivatives are online underneath homework number 20. Our job today is not to grade your derivatives. Maybe to talk about the tricky ones, but not to grade them. Our job today is not to grade your derivatives. You should have already done that. If you were using faulty derivatives to analyze, oh, dang, that sucks. Guys, on the test, what could be, just strategize, you have multiple choice questions. I'm going to pass out the practice test in a second so you can have practice multiple choice questions, kind of all jumbled. what could be a hint or a clue that your derivative is off? Multiple choice questions.
If your domain
Let's say
works,
it's asking for increase here. Let's say it's asking for decreasing.
if there is no domain, but you get, I'm trying to figure out. I feel like there'd be a way like your domain works, but something else is faulty in your derivative. Like
What do you mean by domain? Like DNEs?
Like there are no DNAs, but like something seems off and something isn't working. That's how.
Okay, but what would seem off? Those of you guys that were checking answers in the back of the book for the odds, was there anything that would tune your brain into something seems off? And I gave you the answers to the derivatives, so maybe I kind of shortcutted this process a little bit. Trying to save you time on Friday. If you don't look to the multiple choice answers, and you find a derivative, find the critical numbers, go straight to a sign chart, could your critical numbers not be in their intervals in the answers at all? Does that make sense? So before you even go to a sign chart, for instance, if you had done this guy, and if you had taken his first and second derivative, you got a critical number of 2, and you're like, yay, let's go! And you did all this work, hopefully your work is shorter because you're not writing all of this down. But you did all the work at 2 or for a pip of 2, because we're doing the second derivative 0. Do you think they're going to have lots of 2's in their intervals in the answers in the multiple choice? So a quick strategy as we look at the practice test, as we look at the review, etc. I'm going to pass up the practice test because some of you don't have any questions, some of you have a lot, and some of you frankly haven't finished. But if you look at their answer choices and your critical numbers are not there, what probably went wrong? Your derivatives, yeah. So maybe you should pause, rework your derivative before moving on to a sign chart if your critical numbers aren't matching up. Does that kind of make sense, guys? It's a way to save time. Let me go ahead and pass these out real quick. 1, 2, 3. You guys are checking number 6 and number 8. As you get your practice test, if you read at the very top, I have written directions like skip crossed out problems. There are some horizontal asymptotes on here, which was old school, right? That was like back when we were talking about limits, and there are some limits to infinity. There's a reason why they're on here. We just don't need to worry about it for the test. Does that make sense? So any skipped problems, any crossed out, I should say problems. And Kathleen, you're stepping back here. Any crossed out problems, just don't stress about. But guys, can you follow or track with me on this one? On number 2. Are you going to have to find the first derivative?
Yeah.
Why? Okay, the forever card that you're supposed to be memorizing, EBT is talking about absolute extrema being guaranteed. If absolute extrema exists, we have to check what 2 places. Help us out in critical numbers and endpoints. Do we have endpoints? -4 and -1. But -4 is open. Well, we still think about him if we can. Oh, it's a DNE. I think there's something to that. But anyway, we have endpoints, even though one's open, and we have to be careful of that. But who don't we have? And how do we find critical numbers? The first derivative pitchfork, right? So we have to find the first derivative. Looking at number 2 just as something to be aware of. So we have to find the first derivative. Now, guys, if you find the first derivative, and if you plug and chug, if you think about what your critical numbers are. Let's say you get a critical numbers of something like -3. Can you guys look at all of those multiple choice before you even start plugging into tables and before you start like testing those critical numbers and endpoints or making a sign chart to think of what the function is doing, going up, going down, etc. Do you see a -3 in any of those x spots for any of those mins or maxes? So is it possible that your derivative's off and maybe you should keep looking? Because what I see popping up is a -2. Does that make sense?
Yeah.
And some of you are like, oh, whatever. I should just look at the answer choices and be like, the critical number is -2. Because -1 is an endpoint, -4 is an endpoint-ish. Well, but don't you need the first derivative to figure out the behavior? Because, wait a minute, what does EBT say? If you don't have a fully closed interval, do you remember the sentence? You've been studying it hard. If we have a fully closed interval, we test in the table critical numbers and endpoints. Yeah, if we have a partially open interval, like this guy, we have to think of the behavior. Oh, we have to make a sign chart. Yes. Number 2, I would tell yourself you have to make a sign chart. Number 1, I would give yourself a hint, the green pen trick. You don't use the green pen trick in number 1. Oh, it's sad. Anyway, number 2, you guys have already been able to look at. Number 10, you've already been able to look at. But I was just giving hints for the test. If you find pips or critical numbers and you look to the multiple choice before your analysis and the numbers aren't even similar, you might have made a derivative mistake. Number 28 was a little bit nasty because he was a trig guy, but his derivatives were fast if you had them memorized. The derivatives were really fast. But then you had to find the zeros of a trig function?
Yeah.
Hey, honest trig count. We're talking about inverse trig. Trig backwards. Can you do the unit circle forwards and backwards? Backwards says, when is cosine 0? Oh, at all the pi over 2's. And in the interval, the only pi over 2's is at 90 and 270. Can you make your little intervals or your little number line, and then you test. And you see concave up, concave down. And yes, there are points of inflection at both of them. Remember, intervals. Left, right, left, right, left, right. Points. X, Y, X, Y. Alright, go ahead.
I was just a little confused on how you find the concave during trig.
You have to know your units, bud.
Yeah.
But make sure you plug it into the right one. Remember, learn from me this one. We have, oh wait, no, it's not going on forever. Wait, it's not going on forever. What did they tell us?
0 to pi, 2 pi.
So we have 0 to 2 pi. We're looking at pi over 2. We're looking at 3 pi over 2. Shouldn't you know some angles, some representative unit circle angles in the first quadrant?
Yes.
Pick any of them. Pi over 3, pi over 4, pi over... Wait, what are all of the... Who are you plugging into? Who are all the cosines in the first quadrant? Do you guys see the first quadrant? What's the sign of all the cosines? And a positive times a negative is a... Oh, unit circle in some ways might be easier. As long as you think of, hey, first quadrant, or second or third quadrant? Oh, cosine's negative in all of them. Negative times a negative is a positive. Fourth quadrant, remember, because we're thinking about
Let's take calculus.
calculus makes you understand pre-cal and the unit circle and algebra 2 all better. Anyway, fourth quadrant, cosine is positive, positive times negative is negative. And so then we have our analysis of, careful, that's F double prime, keep track of who you're talking about. I know his curvature, his curvature, his curvature, his meaning the original function. The point of inflection exists because there was a sign change and the original function existed there. Number 40. Oh, look at that nice derivative, guys. See? I'm not saying they never get tricky. You know that the derivatives get tricky, but he was a cubic, he was a cubic, and you had to... Oh, but there was an x in common. Spoiled rotten. And then a quick little binomial that you just had to, quadratic, you had to go from there. Wait a minute. Why didn't they set him equal to 0? What are you doing in number 40? I see you finding critical numbers.
Well,
I see you plugging in
and
critical
second
numbers.
derivative test.
It's a second derivative test for other number 27. You have to look to the first derivative for those they were asking about, weren't they? And the only place we can get relative extrema is the zeros of the first derivative. And then what did they do? Plug it in like we wrote in our forever card. And what did they see? Oh, a negative second derivative means there's curvature down at that horizontal. Oh, it's an x. A positive second derivative means, I don't care the number, what's the sign? Means there's upwards curvature somehow at that horizontal tangent. It's a min. And then negative curvature at that horizontal tangent. Horizontal tangent. That's a max. How many more do we have?
Oh.
We have a max. We have a max and a min and a point of inflection. 72 was a party. He was like a puzzle within an enigma. An enigma within a puzzle? I don't know.
Joe.
Matthew, 36. He came and asked me this morning. P.S. If you guys want a hint about number 72, it's up here on the board. As soon as they said, sorry, he was asking me about number lines and tables for a second. As soon as they said there were relative maxes and mins at these critical numbers, at 2 and at 4, they showed the points. As soon as they said it's a relative min, and they told me it was a polynomial, I know there are no DNEs of derivatives on polynomials because they're smooth. Bless you. They're smooth. So therefore, if you take the first derivative set equal to 0, and plug in x is 2, x is 4, take the second derivative set equal to 0, plug in 3. You know, little baby system of equations. It's a party. It's a mess. It's a party. Anyway, you guys have this on the YouTube video if you want to go and check once again. The concepts are great. In number 72. But the depth, the complexity, the system of 3 equations is not going to be anywhere represented on your textbook. Okay? So you can go check it out, but
That's it.
it's a party. And then number 84 is false. And they gave a quick example of one that would not work. Okay, are there any homework number 20? You guys have gotten your practice test, right? If you're bored, you could be working on it. You have a review. Neither of them, the optional but strongly advised practice test, or the review, which is required, are both due on Friday. Nothing is due tomorrow because some of you need to catch up. Does that make sense? Some of you just need to study those forever cards because if you notice, every time I see a word, increasing, decreasing, point of inflection, concavity, critical number, my brain needs to jump. We have not practiced MDT in forever. My brain needs to jump to a card and pull out information to know how to proceed. Does that make sense? So, do you guys agonize over the practice test tonight? Probably not. Should you guys agonize over forever cards? Definitely.
Okay, I'll agonize.
Yeah? Get 120% on that tomorrow. Should you probably play with the review at least somewhat? Yes. Now, tomorrow, guys, in class, actually, why don't we do it now? Can I have you star just a few problems that as we are going over questions tomorrow is mostly a work day. You're going to pop in, take a forever quiz, and then work day. I'll give you some details about the test, etc. Can I just star a few for you that are very good ones to look at for the test?
Yeah.
And ask me questions about? Okay. Number 1. Number 3. Number 4. Number 6 and 7.
Number 8.
Number 9 and 10. Number 15.
Are you kidding?
Number 16. Well, 16, 18 is probably better. So that's okay.
Well, why 15?
Number 22.
A lot.
Okay, now, there were more that were good. I was just trying to point out some that people make mistakes on. Does that make sense? Because anytime you see concavity, anytime you see point of inflection, anytime you see increasing, decreasing. But do we need to review how to do MDT rules? Yes. So you need to know the forever card first. Do we need to review how to do like absolute extrema or relative extrema? Well, relative we've been working on, but absolute, yeah, but you need to know the card first. What was the one that you guys, or at least Kyle, the one that you groaned on in particular?
I particularly groaned on number 15.
So, some of you might have more questions for me tomorrow, just for right now, since we're thinking towards the test. Can I show you a problem that we didn't get to? I mean, there's tons that we didn't get to. Oh, trig, let's play with that, but you had a trig in homework. Oh, it's a nice little baby polynomial, but let's just keep going. Woo! What's this guy? Use the graph of f prime. Do we have an opener where you were given an f prime and you had to think about it?
Yes.
Okay. This is another good one. There are really just 2 places on the test as far as the one on Friday with the section that we didn't cover where you have to be careful, aware, be using, or making graphs. This is one graph equation. Given the graph of f prime. We have to look at this one tomorrow, okay? Just remind me, we have to look at the graph of f prime problem. But the other graph problem is like number 15. sketching with clues. And it's not so much that the AP says like, hey, sketch with clues, but man, it gives you clues and you have to connect what's going on. So what I want you to do for number 15 right now, can you put a colon after each and every clue and a line? Can you put a colon and a line? If f of 0 equals 0, colon, line, what does that mean? Identify what it means. Identify what's going on. F's behavior. For every single one, put a colon and a line. Behavior of F. So F of 0 equals 0. We'll talk about this, guys, today. What is that of F? If I gave you that, and I said, what does that mean? What is it? It's a point. 0, 0 is a point of F. What do you think I want you to do for the rest of them? So Kyle, in some ways, maybe it's a horrible problem, but in some ways, if I'm giving you a point for every single clue and the graph, man, this thing could be worth like 6, 7, 8, 9 points, and I can ace it. Maybe not that bad. And did you have to take any derivatives?
No.
So what do you need to know for tomorrow?
Everything.
Forever cards. I need you to have the concepts as memorized as possible. Yeah?
Yeah.
Okay. So play with the review. Maybe play with the practice test. But get those forever cards down, because we have to use those concepts as we review. Forever cards. Get them down. Get them down. Get them down.
Now wax. Go wax.
Oh!
And
Why don't you leave your calculator with me? I'll see who picks it up and I'll ask them if you can borrow it. I used to have a plug and someone took it. It was so sad. Because kiddos could charge their calculator.